classwork problem number 16.8. So let's take a look at that classwork problem first. So here it is, the classwork problem. So what are we measuring this time? We are measuring BMI of young women. In part A, we're supposed to give 3 confidence intervals, 90%, 95%, and 99%. After that, then in B, we are supposed to draw some conclusion. So how does increasing the confidence level change the margin of error? First of all, let's figure out what mu represents here. So mu in this population, so what is this population, right? So we have to go back to example 16.1. And here is example 16.1. So there's a government survey that monitors the health of the American population. If you read the first paragraph, you notice that mu represents the population mean BMI of all 20.6 million women in this age group. This age group refers to women aged between 20 to 29. So that's our mu. Now, if you read further, you don't have to. We don't really need the calculations of this example to do our classwork. But if you're curious, you notice that this example uses the 3-number rule to calculate a 95% confidence interval. But for us, the 3-number rule doesn't work because we are supposed to calculate a 90% confidence interval. So we cannot use the 3-number rule. Let's come back to our classwork problem. First of all, we need to write out what mu represents. Mu is the population mean BMI for women aged 20 to 29. Then we're going to use the formula to figure out a 90% confidence interval. So let's draw a diagram here. If the middle area is 90%, that means each tail, left tail and right tail, will each have a size of 0.05. So 0.055 is the area of the left tail. So what we need to figure out is, what are these z values? One negative, one positive. So we need to look up the table to find out the z value for the corresponding left area of 0.05. Here is our z table. So first, let's look up the left area of 0.05. So 0.05 is located between these two numbers, right in the middle. And the corresponding z value is negative 1.6. So actually it's between 0.4 and 0.5, because the left area, 0.05, is right in the middle, halfway between 0.04 and 0.05. So we take our z value to be negative 1.645. I believe we did that last time for classwork. Let's write down what our z value is. So we have a negative 1.645 and we have a positive 1.645, so that the middle area is 90%. For a critical value, we only take the positive z value. Then our margin of error is the product of the z and the standard deviation. Our sigma is 7.5, n is 645. So this standard deviation is 0.2933. So you multiply that by the z critical value, and this is what you get, 0.4823, and that's your margin of error. Sample mean is 26.8. Plus and minus the margin of error. That's the lower bound. And that's the upper bound. So that is your 90% confidence interval. So you are saying that mu lies between these two numbers.